Hey, this is Mr. Mitchell with a video about waves, and we're going to have some things that happen to waves sometimes in this particular video. One thing that might happen to a wave is reflection. When a wave comes upon an obstacle, it generally bounces back at a 90-degree angle. For example, if the incoming light is a wave, comes here on some kind of object, in this case a mirror, it would tend to bounce back at a 90-degree angle. Now, normally, if the light were to be coming straight on with a mirror, it would bounce back in the same exact place. Now, here we do not have a change of medium. The light is bouncing from one thing to the next. It is not going through this particular medium right here. So reflection happens sometimes whenever you come upon an object or whenever a wave comes upon an object. One thing that also might happen is refraction. Now, refraction involves a change of direction of the waves as they pass from one medium to the next. And that's a big distinction between reflection and refraction. For example, here we have someone shining a light. The light goes through the air and then it enters the water, and that's when you get some refraction. You get bending of the light whenever you have changed from one medium to the next. And sometimes it's like the same medium but different conditions. For example, at the ocean, if you are in deep water, the waves start coming in one way, but then when you end up in shallow water, you don't have as much space, and you sometimes have a change of direction that happens to go from there. Sorry about the update thing here. Same thing happens in making of a rainbow. One of the things that occurs is refraction. You have light that goes into this droplet of water, into these droplets of water, and because it has changed medium, it starts to bend. And then eventually you'll have some dispersion of light afterwards. But refraction is kind of the start of that process. So refraction is the bending of the waves that accompanies with a change of medium, which also is a distinction between diffraction. Diffraction involves a change of direction of waves as they pass through an opening or around a barrier. So in this case, we have some kind of opening here. The waves don't go in a straight line, they expand. And the smaller the opening, the more they expand. And you can see what's happening here. You have a little opening, but instead of the waves just going straight through, you have an expansion of it. If you have a bigger opening, yes, you still have some expansion, but it's not going to be as big as it is in the smaller opening. If this student right here is coming around the corner, a radio could be around the corner, but the student still hears the radio, still hears the music from the radio, because the radio waves can bend around the corner. Waves can bend around a corner and go through small openings. Here you have a barrier. You might not be able to see this as well, but you have some kind of light that is going around the barrier and curves on either side, and you can actually see the light once you get just past this barrier here. Now, there is a couple of things to know about the amount of diffraction. One of them happens to be what we mentioned here with the smaller opening and the larger opening, that you get more diffraction with a smaller opening. But you also get something to do with the wavelengths. The wavelengths of the wave is smaller than the obstacle. You have no noticeable diffraction. So if you have very small wavelengths, you're not going to get as much diffraction. And in this case, radio waves have really long wavelengths, and you can get more diffraction there. So the smaller the wavelength, the less diffraction you have. Also want to talk about Constructive and destructive interference. Interference is what happens when two or more waves come together. And it depends on how the peak crests and the troughs of the waves are matched up to see whether it builds upon itself or whether it cancels itself out. Here we have waves where the crests and the trough match up perfectly, and it actually doubles the size of the wave, doubles the amplitude of the wave. And you may remember that with mechanical waves, the more amplitude, the more powerful it is, the more energy it has. But if you were to line them up completely opposite, like you have down here, that would be a destructive kind of interference and could even cancel out the wave altogether. And usually you don't have it where it is perfectly constructive or destructive, but the more they match up, the more energy they have, and the less they match up, the less energy they have. And finally, I want to talk about the Doppler effect. The Doppler effect is something that happens whenever you have traveling sound, and in this case it has everything to do with the sound waves. Say someone is in this ambulance and somebody is driving the ambulance. The person in the ambulance doesn't hear a change of sound. The person in the ambulance hears the siren going through town all the way to the hospital the same way. However, if you are ahead of the ambulance, you hear the sound differently. You hear the sound, and as the ambulance is rushing, the next wave, it makes it shorter because it emits a wave and then the sound, I'll say this again. The ambulance emits a sound wave, and then as it's traveling, it emits another wave and another wave and another wave. And because it is actually traveling into the waves, it creates higher frequency of the wave. However, if you are behind the ambulance, then it creates a wave and goes farther away from it. Creates a wave and then goes farther away from it. So you have a lower frequency, and you kind of hear a ding, 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 ding effect, that you have a different frequency in front of the ambulance as you hear it behind the ambulance. However, the person in the ambulance does not hear any difference. So that is what is called the Doppler effect. Hope you've learned a little bit about these things. Thank you.